Migration to OpenFrame. During a rehosting project, primarily there are three components that needs to be migrated from mainframe to OpenFrame. First is data, second is application, and third is presentation layer, that is BMS maps. Let's talk about the migration process in detail for these three components. Data migration. OpenFrame supports different datasets including PS, PDS, JDG, and VSAM files. OpenFrame also supports fixed length, variable length, and multi-record layout datasets. For the purpose of demo, I'm choosing a simple physical sequential file, but the process remains the same for almost all the different datasets with few minor variations. Sequential dataset migration. On the left-hand side, you can see the mainframe which runs on the FCD character set, and the right-hand side, you can see the OpenFrame which runs on the ASCII character set. And as part of the data migration, we're going to convert this FCD data into the ASCII. So for this process, we need two inputs from mainframe. One is the file itself transmitted in the binary mode from mainframe to the OpenFrame. And the second one is COBOL copybook layout to interpret the file. Once you have the FCD data on the distributed system, if you try to view the data, you'll not be able to interpret the data properly. Let's take a look at the example. This is the file that was copied from mainframe in the binary mode. And if you try to open this file, as you can see, it is not readable. Now let's take a look at the COBOL copybook that is associated with the dataset. As you can see, this copybook has 5 different fields: employee number, employee name, address, contact, and date of birth, and everything is a character. In this case, it's a simple example. But OpenFrame supports different data types including characters, numeric, COM3, zone decimals, and the conversion rules are different for each and every data type. And hence it's important to identify the layout such that the migration utility knows how to migrate each and every byte of data. So once you have the COBOL copybook, the first step is to generate the schema file or the rule file using a utility called cobgen.sch. Cobgen.sch stands for COBOL generate schema. Let's go ahead and try to create the schema file. The command here is cobgen.sch followed by the COBOL copybook. And you can see it generated a schema file, and this is the location. Let's try to view the generated rule file or schema file. Here you can see the rules that are being present. This is a group level variable. The second one is the employee number, and it says convert from FCD to ASCII for the 5 bytes, and the similar rule for all the remaining fields as well. Since we have the schema file and the dataset in the FCD mode, the next step is to execute the utility dsmigin. dsmigin stands for dataset migration input, and it's used for converting from FCD to ASCII based on the schema file. So let's go ahead and execute this utility. Before actually creating the output datasets, let's go ahead and verify if the dataset exists in OpenFrame or not. Here you can see the dataset doesn't exist. Now let's go ahead and execute the utility dsmigin. As you can see, the usage of the command is dsmigin followed by the input dataset followed by the output dataset, and the final parameter is the rule file. And you can see the record format is fixed, and it says the record conversion count is 16 and there are no error records. And now let's go ahead and try to see if the dataset exists now. Here you can see the dataset is created. Earlier the same data was not readable, but once we converted the FCD to ASCII, now the data is in much more readable format. This explains the migration process for a PS file, but the process is similar for JDG and VSAM files as well. For VSAM files, you need to do an additional IDCAMS repro to copy the generated ASCII file into the VSAM file. COBOL code migration. The compilation process in OpenFrame is very similar to mainframe. Let us take an example of CICS COBOL program that accesses database. The first step of compilation process is CICS preprocessor, which replaces the exec CICS statements with the equivalent COBOL call statements. OSC CBL-PP is a CICS preprocessor provided by OpenFrame. OSC stands for Online System for CICS, CBL stands for COBOL, and PP stands for preprocessor. The second step is database preprocessor. Typically, the database vendor provides their own preprocessor. In this scenario, we are using Tibero database, and hence the preprocessor name is TBPCP, which stands for Tibero preprocessor for COBOL. And the final step is the COBOL compilation. OpenFrame provides its own COBOL compiler called OF COBOL, but it can also integrate with third-party compilers if required. And OF compiles the COBOL code and generates the executable load modules. At the bottom, you can look at sample usage of various commands. You can compile program either using the shell scripts or using IDE tools like OF Studio or Eclipse. We'll now look at a sample program compilation using OF Studio. OF Studio is Eclipse-based utility that is installed on developer desktop for compiling and deploying the changes to OpenFrame. Once you create the project, import the source and make your changes to the source, then you can easily compile and deploy the source using OF Studio. So here I am trying to compile the customer inquiry. I made my changes and click on the compile. And then it asks for the server selection. So choose the demo server and say compile. And then it asks for the tmax port number, and also you need to authenticate before you deploy the changes to the server. And here you can see the message saying that the compilation process was successful. And now let's test the deploy function. So before we deploy the code, let's see the existing timestamp of the load module. So as you can see, the timestamp says like 4:37 p.m. Now let's go ahead and try to deploy the changes. Click on the deploy button and again choose the server as the demo server and choose the load modules that you would like to deploy and click on the deploy. And here you can see the message notification saying deploy is successful. Now let's go ahead and verify the timestamp. Here you can see the timestamp has been updated. We looked at compilation and deployment of code using OF Studio, but you can also use Eclipse for doing the similar functionalities. But some of the developers are very familiar with Eclipse and they would like to use Eclipse for making any changes to the code and doing the compilation and deployment. So now we'll go ahead and see how you can compile and deploy the code using Eclipse. Eclipse provides a plugin called Remote Systems, and once you install the plugin, you'll be able to browse the code on the server. And let us choose a sample COBOL program, which is the same program as before. And here you can configure the user actions. And I have already configured the user actions for compile and deploy. So I'm selecting the source that I would like to compile and click on the compile button and say, okay, run this particular command. And here you can see the compilation is successful. Now I would like to deploy this module. Let's look at the timestamp before deploying. The timestamp is 7 p.m. And now let's go ahead and click on the user actions and then COBOL deploy and say okay, run. And here you can see a message, success message saying deployment is successful. Now let's go ahead and refresh the timestamp. And here you can see the timestamp is 7:04, meaning the deployment is successful as well. BMS map migration. BMS map migration is straightforward in OpenFrame. Once you have the source for BMS maps, you just need to compile the maps using the utility called MSC Mapc. MSC Mapc stands for Mapping Services for CACS Map Compilation. And similar to mainframe, it generates two components. One is the physical map and the second is a symbolic copybook. Now let us take a look at the sample map code first and then try to compile it. I open the map din-map1. As you can see, the source code is exactly the same in mainframe, not even a single line of change. The command for map compilation is MSC Mapc followed by the region name. In this case, it's a demo region name, OSC OVP1, followed by the mapset name, din-map1, and press enter. As we discussed before, it generates two components. One is the symbolic copybook that is located in this location, and the second one is the physical map. You can take a look at the symbolic copybook. You have the input and output files as in mainframe. OpenFrame map compilation also provides an additional option called preview. Here I'm using the options -p and 1. Preview, one option. If you use this option, what it does is it previews the map during the compilation time. You can look at the exact map layout, how the map is going to look like. This option is not available in mainframe. This option would enable to modify the map even before invoking the transaction. OpenFrame also provides the option for updating the map at the runtime, which is similar to issuing a new copy on mainframe. The command for issuing a new copy is MSC map update. As you can guess by now, it stands for Mapping Services for CICS and map update, followed by the region name. And you need to specify the location where the physical map was generated. So let's go ahead and execute this command. So I'm executing the new copy, and it didn't give any error message, meaning the new copy has been successful. This completes the demo for migration to OpenFrame and Studio. Please watch the remaining videos for other topics.